Hello, this is Dr. Rehman Ali with chapter number 3 Relational Data Model of the course Introduction to Database System. We are following the book of Carlos Cornell and Stephen Morris. This is the part second of this book with the design concepts covering 4 chapters, but we are discussing relational data model at this moment. Different learning objectives have been set that after the completion of this relational database model, the student will be able to understand these concepts. And what we will be focusing from this chapter will be covered in 2 parts. Part first will relational database model terminologies, keys, integrity rules, and the second part will be discussing relational algebra. Let's jump into part first, covering the definition and understanding of relational database model, logical view of the data, and relevant terminologies. Let's start with the definition of the relational data model. So when we are talking about relational data model is actually the representation of the data into different tables. This is the tables, and each table is consist of 2 components, rows and columns. So whenever the data is represented in rows and columns, we call it a table. And this terminology was introduced by EF code in 1970, and the software that are used for the relational database development are PostgreSQL, SQL Server, and MySQL. So these are the different relational DBMSs that can help us to implement these relational data model and relational databases. Now, how data is logically represented in a relational data model, as we already discussed that relational data model or relational database model, this is the same terminology, and this relational database model or relational data model, they are actually the logical representation of the data, not the physical. So in this relational database model, we will be not talking about how data is stored into the physical storage, but how it is logically represented, and its logical representation is in the form of tables. For example, we have an entity student, so the student data is represented into columns and rows. Each column represents the characteristic of a student. For example, student GPA is one characteristic, and student date of birth is another characteristic. This is called column. And one complete row, for example, this row represents one student. So here we have around 11 records, 11 rows. So this logical representation storing 11 students' data in the form of rows and columns. And this rows and column representation of data is called table. And the advantage of this is that it hides the physical storage details from the user. The user is not concerned with how this data is stored inside the computer. Now, as we discussed, that logical database model it represents data into table. So let's see some of the characteristic of a table. This is a table storing the data of the students, that is student ID, name, gender, GPA and address. So this table has three different terminology. It could be called as table, it could be called as relation, and it could be called as entity instance. Table, as we already discussed, the rows and column representation, that is the two-dimensional representation of data is called table. But when we talk in terms of mathematics, then it will be called as a relation. It will be called a relation. And if we talk in terms of how many records it is storing, for example 1, 2, 3 up to 100 students data is stored inside this table. So this is called entity set. This is called entity set, means set of 100 student is stored inside this structure, and overall this table is called as entity set. Apart from this, some other terminology that are used as this is called attribute, and each row is called tuple. So this is called, each row is called tuple, and each column is called, this one, it is called attribute. And each attribute has a characteristic which is called attribute domain. Attribute domain. By attribute domain we mean that if we talk about this gender takes the value of M or F, that a gender could be male or female. So the setup allowable value for this attribute is that its value will be within the range of M or F, and this is called attribute domain. And similarly, if we talk about the GPA, so GPA could be between 0 and 4, and this is the domain of the GPA. Now there are some other characteristic or rules that must be followed by a table or a relation. So let's talk about those rules. Now let's see, we have 8 golden rules. Rule number 1, 2, 3, 4, 5, 6, 7 and 8. Now let's explain all these rules that a table should have qualify these characteristics. We will be explaining them one by one. So let's take the first one. Two-dimensional. By two-dimensional we mean that this is one dimension column and this is the second dimension. So a table should have two-dimensional representation. The second rule is single entity per row. By single entity per row mean that this is the data of one student, this is the data of another student. So one row will represent the data of only one student. And the third characteristic is unique column name. By unique column name is that if you can see student ID, name, gender, male, but if you put GPA again here instead of this address, then in this case the column name are not unique. You can see that this GPA and this GPA, they are same. So this rule will not be qualified. So this is the rule number 3. These column names should be unique. The fourth rule is single data value. By single data value mean that each column should carry only one value, not two. But in this case, if you see, it carries Swat, Pakistan. It carries two values. Swat is actually, this Swat is the city, and this Pakistan, this is the country. So this column takes two values, and this is not allowed. So we have to look into these single data value, and this characteristic is called atomicity. Another characteristic are the rule as column homogeneity. By column homogeneity we mean that if we take this gender and we write M and F. So M and F, that is, its data type is textual. But if I go and represent it like this, in some of the value I use 0 for female and 1 for male, now it violates its column homogeneity values characteristic. Here it is character type and here it is integer type. So one column should not carry two different data types. This is called column homogeneity. And let's see the next domain constraint that we already explained in our last slide. This is F, this is, for example, M, and this is F. So this whole column gender, its range is, its set of values is M or F. So this is the domain of this college. And the second last characteristic is order independence. Order independence, we mean that if you bring this GPA here and this gender from here to here, it will not hurt the DBMS, and DBMS will not encounter any problem. So you can switch the columns position. And the last but the most important characteristic of a table or a relation is primary key. Primary key is any attribute whose value uniquely identify a record within this table. For example, 1, 2, 3. No value should be duplicated, and no column, it should not be null. We will be talking about this in detail, but each table should have a primary key. So this is all about the introduction of relational data model. Thank you.